what are some of the lifestyle habits that you think accelerate cognitive decline?
Oh, now look, that's a double-edged sword right there. I think many lifestyle habits can accelerate cognitive decline, such as our diet, what we're eating. We now know that insulin resistance, sugar, high glucose can cause an inflammatory cascade, which can then trigger a neural inflammatory response, which can then trigger cognitive decline. We know that sleep deprivation, lack of quality sleep, inconsistent timings can accelerate the rate of cognitive decline. We know that exercise is probably the most powerful intervention that we have. So not exercising, not getting proper blood flow to the brain is also detrimental.
You mentioned sleep. That's something that I think most people now are aware of, the importance
Yes.
of it, right? But talk about, like, go in and if you could go in as in depth as possible as why sleep is so important to master when it comes to cognitive health. I think the audience would really appreciate that.
Well, let's just understand what we're talking about when we talk about cognitive health. So we have a brain and a nervous system, and over time we build up these connections. We have around 87 billion neurons in the human brain, and all of those connect with one another. You've got around 5,000 connections per neuron. So it's like trillions of connections that are happening. And over time, we lose those connections. We lose the ability for one neuron to connect to another. And when these neurons connect to one another, they produce a chemical reaction. We know that it's called a synapse. And this is responsible for our thoughts, our movements, everything. And that's what forms our cognition, the way we think, processing speed, everything, right? So what happens over time is we lose those connections. And we'll talk first about sleep, but that's what cognitive decline tends to mean. And when we're looking at dementia, we have to understand that dementia is the umbrella term used to describe a set of cognitive decline symptoms. So the reason why we know Alzheimer's disease so well in society is because Alzheimer's disease is a form of dementia, and it's the most prevalent. We've got 55 million people worldwide that have the disease. That number is said to triple by the year 2050. So it's a very prevalent disease. Around 6 million US adults have Alzheimer's disease currently, and there is no cure. So a pre-dementia state or a pre-Alzheimer's state is what we call mild cognitive impairment, where you're getting these cognitive complaints or cognitive impairments that seem to be mild. I don't think they're very mild. And one of them is generally driven through not cleaning out the brain. And this brain cleaning process takes place during sleep. So sleep is fundamentally a tool that we have at our disposal. It's free. We get it mixed up because a lot of things interfere with sleep: stress, alcohol, drugs, cigarettes, timing, a partner. And when we think about sleep, we're generally looking at two stages. We look at REM sleep, rapid eye movement sleep, and we're looking at deep sleep or slow wave sleep. And they're the two things that I really want to focus on right now, because during deep slow wave sleep, it's around stage 3 sleep, we're getting many things that occur. One is we get the release of a lot of our hormones. So estrogen for women, testosterone is significantly produced during deep sleep. We get the release of growth hormone, which is responsible for tissue repair, muscle regeneration. We're also getting the activation of our lymphatic system. And what happens is overnight, the cerebral spinal fluid washes through the brain and it pushes it out through this perivascular space, and it just gets excreted through our body, right? And when it gets washed out, and we've got these specialized astrocytes that are they've got legs on them, they're kind of pushing out the cerebral spinal fluid as well. What happens is they take the debris and the toxins that build up. And it's my understanding that these toxins, such as amyloid beta and these tau proteins, when they build up, they actually, the amyloid beta, for example, they interfere with the networks between the neurons. So if we don't clean it out during deep sleep, we don't clean out these toxins, it interferes with these networks, and these networks can't communicate with one another. So sleep, and we're now seeing more data on actually the consistency of bedtime and wake up times to being the most important. So maintaining a good sleep hygiene protocol is really, really important for a healthy performing brain.
So I think with that said, I think people think that they can just catch up on sleep. Like if they just go through a few weeks and have poor sleep, that eventually it'll be okay because they can catch up. I've heard you kind of touch on this and why it's not really the case. Um, like why, like what are the like long term negative
Yeah.
effects of like deprivation?
Well, first and foremost, because your brain loves consistency, you want to maintain a consistent sleep environment. As I mentioned, we're now seeing the most data of good sleep hygiene coming out with the times that we go to sleep and the times that we wake up. And apparently, it doesn't matter what time you're falling asleep. So if you're falling asleep every night at midnight, make sure that you are staying within 10 standard deviations of that midnight every single night and waking up every single night at the same time. But it does not mean that you can sleep 3 hours one night and 12 hours the next, because even on that one night, what happens is your brain still has the ability to build up these toxins. And sometimes it becomes a bit of an overload. We've got this, when it comes to cognitive decline and Alzheimer's disease, we've got a supply and demand issue. We've got this demand, whereas like we've got a demand every day of going to work, putting up with, emails or co-workers or whatever stress that you have. So there's a lot of demand there. In order to meet that demand, you have to have a healthy brain. But if you've got this brain that's full of these toxins, it's an unslept brain, and it's at the mercy of all of this demand, you're not going to be able to meet the demand. So the demand takes over and there's not enough supply. So you have to think of sleep as a regenerative tool that is fueling your brain.
So I think with all that said, people, they think about cognitive decline as like forgetting things, not having a good memory, like losing sight of people's names, etc. What do you think are some of the like hidden signs of cognitive impairment that people might not be aware of?
Look, some of the first and earliest signs are episodic memory and short-term memory. What we're seeing is when we see somebody who's got subjective cognitive impairment, which is actually a dementia state before mild cognitive impairment. And what we're seeing is that people start to lose their short-term memory in terms of they can't think of people's names. They can't think of where they left their keys. Now, I don't want that to be mistaken with somebody who's just stressed. I don't have mild cognitive impairment, but sometimes I do forget people's names, or sometimes I do forget where my keys are. That doesn't mean I have mild cognitive impairment. For anybody listening and they're thinking, well, how do I know if I have it? You can go and do something online called a MOCA test, MOCA. It's the Montreal Cognitive Assessment Test. And it's out of 30, and you generally want to hit a score of 30. If you hit a score of 18 or below, 18 is classified as mild cognitive impairment. So anyone can go and do this. And it's a really great assessment online backed by heavy data. And then you want to then get about the business of slowing the progression, because you don't want to get into a place where, and this lasts around 10 years. So you don't want to get into a place where you end up getting to the Alzheimer's space. So some of the early signs, like I mentioned, are episodic memory, short-term memory.
And then when it comes to like, I think people like, they think about this like, oh, I'm only like 25, I'm 30, I'm 35. Like this could not happen to me. I'm sure I'm just stressed. What's a normal age that you think somebody should be experiencing cognitive decline?
Well, I don't think there's any normal age, because I don't think that cognitive decline is a normal part of the aging process. We now have substantial evidence to show that Alzheimer's disease is now becoming optional. And that's a controversial statement, but it is. And so what we have to understand, though, is that Alzheimer's disease is a brain state where your brain has said, I give up. So it means that over the last 20 or 30 years, it's been fighting for survival. So in your 20s and in your 30s, these are when you are building Alzheimer's disease. You
Wow.
can either stop it or you can contribute to it. And we contribute to it in our 20s and 30s because that's when we feel the most invincible. That's when we think we don't need sleep. That's when we think that we can get away with the drinking, right? I remember, I'm early to mid 30s, and if I have a glass of wine now, it completely affects me compared to, I remember, being maybe, I remember having 3 or 4 drinks in my 20s and 30s and waking up and just slamming out a 20K run the next day. I remember those days so clear. I'm like, oh my God. So everything you're doing now in your 20s and 30s really affect how you decline.
So you mentioned that it's controversial that Alzheimer's is optional. And I think people have had this idea for some time that a lot of these diseases, including Alzheimer's, are mainly genetic. I think I've heard you say that Alzheimer's and cognitive decline, in fact, is mostly lifestyle related. Talk about why that is and talk about why that is.
Well, let's determine and differentiate between genetic risk factors and genetic mutations. So we have around 20,000 genes in the human genome. And when we talk about a genetic mutation, it is a disruption on that genetic code. For example, if we now know that there's around 30 genes involved in dementia, and if we have 3 of these genes, we know that it's a foregone conclusion that you will get the disease. They are, and these are mutations. They are presenilin 1, presenilin 2, and the amyloid precursor protein. We also hear of the risk factor genes, such as ApoE4. And people think that, if I have the genetic variants of ApoE4, it comes in 2 alleles because you get one from mum, one from dad. If I have 2 copies or even 1 copy of the gene, I'm going to get Alzheimer's disease. But that is not true, because Alzheimer's disease, if you look at the broad spectrum of all of the people who have the disease, around 98% of these people don't even have the genes responsible for the disease, not the presenilin 1, presenilin 2, or the ApoE4 genes. So we can now say that Alzheimer's is largely driven through lifestyle. It doesn't have to be a genetic makeup. Yes, if you have the ApoE4 gene, you have a higher, you are predisposed to the disease. You have a higher risk, 12 times higher risk of getting the disease. Does not mean that you will get the disease. You've just increased your risk of getting it through your genes. But then we have so much information on these genes now that we can then provide a conclusion to say, well, great, you've got the genes. Doesn't mean you're going to get the disease. So what do we have to do now? And that's when it's time to take your lifestyle really seriously. For example, the ApoE4 gene is really responsible for transferring cholesterol in the brain. The brain needs cholesterol, and it gets transported through the brain and utilized and uptaken by the neurons to be used as energy and fuel. When you have a mutation on that gene, or when you have the ApoE4 gene instead of the protective ApoE gene, which is ApoE2, it doesn't help with the transfer of lipids. So what ends up happening is you end up getting these atherosclerotic plaques that build up just like in cardiovascular disease, but they build up in the vessels of the brain. And that can then lead to cognitive impairment, slowing of, we can have atrophy of the actual brain cells. It can even lead to stroke.
Wow. That's wild. So you mentioned this MOCA test. I just plugged it into my computer so I can be sure to take it just to see where I'm at. Hopefully I'm at a 30. And then you talked about cognitive impairment and what leads to that. Like, let's just say somebody takes this test and they're at a score where it's clear they have cognitive impairment based on that and the way that their life is going. Is there, like, what's the best way to either reverse it or slow down the progression?
I want to talk about slowing down the progression instead of reversing it, because I think reversing is a term that comes with a lot of like bullets, right? So we need to reversing something is really, I would say it's got to be a very, very strict, structured lab work protocol. So
Mm.
let's say that we've been diagnosed with MCI. How do we, instead of getting Alzheimer's disease in 10 years, how do we get it in 20 years instead? So that's slowing the progression. The first thing that we have to do is look at inflammation. Inflammation sends a signal out to your system to activate what we call the innate immune system. And if we look at the amyloid beta, which is that toxic protein that builds up in the brains of Alzheimer's disease, amyloid beta is actually an antimicrobial peptide. So it gets when you activate your innate immune system, which is the body's first defense mechanism against an insult, right? So basically, something happens, you increase inflammation, you get this all these cytokines that go out, and it basically says protect the body from a threat. That's when amyloid beta is. So amyloid beta is not it's not harmful, right? It's only harmful in a toxic load. So it gets built up to protect your brain. And it says, we've got to protect the brain. But what happens is, once it's there, you have to have a mechanism of clearing it out. And the only way to clear it out really is via the lymphatic system during sleep. So that's the first thing. We need to manage our inflammation. From that, we can then categorize different things, such as I'm now looking and doing some studies on looking at toxic mold exposure, for example. So things such as environmental toxins in the air can build up in the system. They can travel through the nose, go up to the brain. Toxic mold in apartments can also interfere with this process. So that's one aspect that we can be looking at. We can also look at your glucose control, getting a standard, HbA1c, looking at fasting insulin, looking at your HOMA-IR, going to a doctor who's well trained in blood work and interpreting blood work can help you along that path as well. And it becomes then a moment of how can I manage my glucose and glycemic control? You also want to be maintaining a diet that is right for you. So you want to look at your lipid panel. That is a measure of your LDL, your HDL, your triglycerides, your cholesterol, your ApoB. Remember, what's good for the heart is good for the brain. So you don't want to become into this state of your cholesterol is too high, your LDL is too high, because your brain is the most vascular rich organ in the entire body. It has so many blood vessels that you need to take care of. So we need to look at that. We need to modify the diet, eating a keto-rich diet as well. So your brain loves ketones and beta-hydroxybutyrate. So looking at that, then you really want to be exercising every day. Walking, we've seen so much research to show that even 1 mile of walking per day can slow the progression and onset of diseases such as dementia, mild cognitive impairment. Resistance training, which is my field of study. We know that when we do resistance training, that dramatically reduces the risk of Alzheimer's disease. And then, of course, sleeping and the community that you are involved with, making sure that you've got good social connections, good people around you, a place to speak and a place to be inspired.
Right. So as far as specifics, like if we were really trying to slow the decline, the cognitive decline, and slow that progression, how much resistance training per week should somebody be doing? How much sleep, quality sleep, should somebody actually be getting if they're in that stage where they're actually now in a place where they have to like pay attention to how they're handling their brain health?
I always recommend people sticking to 3 hours per week of zone 2 training, which is around 65% of your maximum heart rate. And then looking at around 2 to 3 sessions of resistance training per week, making sure that it's fun, making sure that you like it, because adherence to a protocol is probably the most important thing that's going to move the needle forward.
Right. And then what about sleep?
And then sleep, I think that every human needs to be sleeping at least 7.5 hours per night.